Someone who's watching us right now, they do not know what quantum physics is. I just wanted you to explain it to them in layman terms, simplest form.
Okay, so everybody is familiar with classical physics. That's how does a car drive, an aeroplane fly, or even if you roll a ball down a hill. But what the quantum is for, the quantum physics is to look at things that are really, really small. And when I mean small, I mean the things that make up everything in the universe. And so it's the physics of the really, really, really small. Much smaller than an ant, much smaller than a virus or bacteria, the really, really small.
Yes. It's an international year of quantum physics. How is that bringing change into the quantum physics community?
So we're celebrating this year 100 years of quantum physics. So that means if you go back all the way 100 years ago, before that, people really didn't know about all of these interesting things. So there were people born before us who asked these questions, carried out investigations, experiments, did some mathematical equations, and built up this picture over 100 years that we now have of the quantum world. But of course, the story's not over. It's continuing. And the more we learn and the more we study, we actually realize how little we know.
This is SA Science Spotlight Podcast, and joined in studio with us is Professor Mark, who is going to be sharing some light on quantum physics. So today, as you guys know, we're covering SAIP Week, and we want to give you everything that we can as SA Science Spotlight Podcast. Prof, welcome.
Hi.
How are you?
I'm good, and you're doing very well.
Thank you. How's the week been?
Well, it's first day, and it's been some very interesting talks in the session we had this morning, so it's been fun. Yeah.
So you did your presentation.
Yeah.
How is it?
Well, you should ask the people who had to listen to it, but I thought it went very well, and I didn't see anyone sleeping, so that's always a good thing.
Did they clap hands after?
Big clap.
That's a good sign.
And then I was asked to
one.
come here and talk to you, so it must have been good, right?
Yes, it was. So, Prof, firstly, I just wanted, for someone who's watching us right now, they do not know what quantum physics is. I just wanted you to explain it to them in layman terms, simplest form.
Okay, so everybody is familiar with classical physics. That's how does a car drive, an aeroplane fly, or even if you roll a ball down a hill. But what the quantum is for, quantum physics is to look at things that are really, really small. And when I mean small, I mean the things that make up everything in the universe. And so that is atoms. How do atoms behave? And atoms are made up of electrons. How do electrons behave? And so it's the physics of the really, really, really small. Much smaller than an ant, much smaller than a virus or bacteria, the really, really small. So it's the physics of things small. And what's interesting about things that are small is they behave very, very differently.
So how does, you are in quantum physics, right?
Yes, that's right.
So how does your work surround that field? What are you doing in that field?
Okay, so as I said, if you're not familiar with the structure of matter, what we're made up of, it's made up of things called atoms. And if you look at an atom has something called a nucleus, which you can think of like being a sun. And then around the nucleus, spinning like planets around the sun, are the electrons.
Yes.
And my research is to study the electrons. But to study something, you first have to have it. If I want to see what this water does, I need to have the water in my hand, that I can look at it, that I can pour it. So what I have to try to do is first capture an electron. But I'm trying to capture something that is unimaginably small. And once I've captured it, then I can study it and see how it behaves. So that's what I do in my lab, and I do that in the University of Cape Town, and I have what's called a dilution fridge. And actually, it's a fridge that is very, very cold. In fact, inside my fridge is probably the coldest place in Africa. So if you want to see the coldest place in Africa, you have to come to UCT Physics Department.
I'm already booking my flight.
You can have cool beer. We cool electrons down inside the fridge, and when they're very, very cold, then we can begin to trap them and then study them. Yes.
So recently, what have you been studying about electrons?
Okay, so everyone knows of computers, and inside a computer, even the camera that's filming us now or your cell phone, there's something called a transistor. And really what a transistor is it's like a switch, an on and off switch. And the way in which a transistor behaves or how it operates requires you to understand quantum mechanics, because the way a transistor works is due to electrons. So if you want to understand how a car works, you have to study the car's engine. You have to know how the wheels turn. You have to know how petrol works. But for a transistor, you have to study electrons. So I am capturing single electrons to understand what's called single electron transistors. And so those transistors one day can also be used for a new generation of computing known as quantum computing. So I'm building what's known as single electron pumps. And so really what it is, it's a tiny device made in semiconductors that at low temperatures can trap an electron, and then when I have the electron, I can study it in something called a magnetic field. And a magnetic field, I'm sure you've felt two magnets, like
yes.
on, sticks on the fridge. If you have a fridge magnet, or two magnets, you bring them together. If they're north and south, they stick together. Well, that means that those magnets produce what's called a magnetic field. And if you have an electron moving in that magnetic field, it behaves differently. And because I can trap one electron, I can see what it does. And so if I can understand what the electron does in a magnetic field, then hopefully I can use that. And my students, I've got lots of very good PhD students, master students, honors students, and even some undergraduate students who all work together to understand how the electron behaves, such that we can help contribute to building quantum computers. Yeah.
Interesting. I'm now seeing why people didn't sleep, because
Oh yes, did I keep you awake? But you said you had coffee first. I'm worried if it's the coffee that's keeping you awake.
No, it's actually it's also building a lot of questions. But I also wanted to mention that this year they said that they're dedicating it to quantum physics.
Yes.
It's an international year of quantum physics. So I wanted, how is that bringing change into the quantum physics community?
So we're celebrating this year 100 years of quantum physics. So that means if you go back all the way 100 years ago, before that, people really didn't know about all of these interesting things. They didn't know how electrons behaved. They didn't know what you could do with them. They didn't really understand exactly how an atom worked. When I said to you, an atom's like got a nucleus and it's got an electron, which is like the sun and the earth rotating around the sun. These models were not around more than 100 years ago. So there were people born before us who asked these questions, carried out investigations, experiments, did some mathematical equations, and built up this picture over 100 years that we now have of the quantum world. But of course, the story's not over. It's continuing. And the more we learn and the more we study, we actually realize how little we know. We'll never know everything. We're just getting closer and closer and closer. But however close we get, it seems to move further away. Because the more you learn, the more you realize there's still to learn. So we have only accomplished 100 years of theory and experiment, and there's lots more to go. But these 100 years it's very worthwhile celebrating, because if it wasn't for the work of the people 100 years ago, and over the last 100 years, we wouldn't have the cameras, the cell phones, electronics that are flying airplanes, and so that's what we're celebrating. All the work that the people in the world have done to get us where we are today in understanding quantum. It's a good celebration.
Exciting.
And it's for everyone.
And it's for everyone.
Yeah.
But now it has me thinking. We're now celebrating 100 years, 100 more to go, maybe 1,000 more
Hopefully,
to go.
yeah.
Hopefully.
Yeah.
So what is South Africa contributing in this community?
So I think the beauty about science is, and now with modern technology, like your podcast, you're going to go put this online, and hopefully there'll be students and people all over South Africa, but even all over the world, who learn a little bit about the quantum world. And we in South Africa are contributing, firstly and very importantly, creating a new generation of scientists, young people coming from all walks of life in South Africa, who hopefully will add to that knowledge base that was created 100 years ago, started, and have built up over the next 100 years. But as you said, we want to go further and further, and we want to go south. We need new people to learn, to understand. South Africa is making sure at Wits University, UCT, Pretoria, Stellenbosch, Venda, all over, where there's a university, students should be studying physics and science. And then they can help contribute. And South Africa is making sure we have young people in Africa who will learn science. And we also have research. So at my research lab looking at electrons and magnetic fields. That's contributing. Here at at WITS, there's labs working with lasers, all adding to this global knowledge. Because remember, it's for everyone.
It's for
Just because
everyone,
it's done
yes.
here doesn't mean it's only for South Africa. Just because research done in London is only for London. It's for everyone. And we have labs in Africa with young scientists, your age and older and younger, who are all contributing, and we are part of that. And that's important for us in South Africa.
Prof, before you go,
Yeah.
I just want you to look into the camera. I want you to give out a message to young scientists which are coming, young physicists who have big dreams. It can be someone who's in undergrad, someone who's doing their PhD, or someone who's just stuck with a degree and they think they can't do anything about it. So,
Well, my
yes.
message to all young South Africans studying hard, working hard, is that getting into science is very rewarding because it is difficult. I remember I was a student here at WITS, I won't tell you how long ago, but a long time ago. And I found physics hard. That's why I wanted to study it. I didn't want to study something's easy. What's the point of doing something easy and just stay at home and read a book or watch TV or Netflix? I've never had Netflix when I was a student. But I think what makes you feel good is when you do something that's difficult and end up doing it well. And physics is very rewarding because you're changing people's lives. Think about the person who discovered the transistor that's inside your cell phone. Look how-
Inside almost every gadget here.
and that helps. So you can make a difference to people's lives. And the way to do it is to read as much as you can, work hard. Not only work, because you want to have fun and play, but spend as much time as you can studying the hard things and always get help. Don't think you can't go. I find, because I lecture at UCT, I find students are scared to come ask questions. Always ask questions. That's the best way to learn.
Thank you, Prof.
Okay.
It was amazing. Thank you.
Great. Thanks for your work. I think it's very good you are